So today's lab is scale and load balance the architecture. So in this lab, we walk through using the elastic load balancing ELB and auto scaling services to load balance and automatically scale our infrastructure. So elastic load balancing automatically distributes incoming application traffic across multiple Amazon EC2 instances. It enables us to achieve fault tolerance in our applications by seamlessly providing the required amount of load balancing capacity needed to route application traffic. Auto scaling helps us maintain application availability and allows us to scale our Amazon EC2 capacity out or in automatically according to conditions we define. We can use auto scaling to um, to help ensure that we are running our desired number of Amazon EC2 instances. Auto scaling can also automatically increase the number of Amazon EC2 instances during demand spikes to maintain performance and decrease capacity during lulls to reduce cost. Auto-scaling is well suited to applications that have stable demand patterns or that experience hourly, daily, or weekly um, variability in usage. So in this lab, we will able to create an Amazon machine image AMI from a running instance, create a load balancer, create a launch template and an auto scaling group, automatically scale new instances, create Amazon CloudWatch alarms and monitor performance of our infrastructure. So this is the diagram of this lab. This is AWS cloud, this is region, and there is two zones, availability zone A and zone B. This is the VPC. In the VPC there is two public subnet and two private subnet. This public subnet there is NAT gateway, and here in the private subnet there is a security group web instance, and there is security group RDSDB primary and RDSDB secondary. So here is auto scaling group, and here internet gateway and security group, the application load balancer. Now we will start the lab. First, we will create an AMI for auto scaling. For this one, we'll go to the EC2 instances, and here is web server 1 instances running. This is running. So I will select this web server 1 action, image and template, then create image. So the name should be web server AMI, image description lab AMI for web server. Then I will create the image. So it says that currently created AMI. Now I will create a load balancer. For this task, we will first create a target group and then we will create a load balancer that can balance traffic across multiple EC2 instances and availability zones. For this one, we'll go to the target groups. So target groups define where to send traffic that comes into the load balancer. The application load balancer can send traffic to multiple target groups based upon the URL of the incoming request, such as having requests from mobile apps going to the different set of servers. Our web application will use only one target group. So I will go to the create target group. So select the instances, mm, name, lab group, VPC is lab VPC. So I'll go to the next. This is the registered target. This screen appears. Targets are the individual instances that will respond to requests from the load balancer. We do not have any web application instance yet, so we can skip this step. So we can create target group here, left load balancer. There is no load balancer, so I will create one load balancer. So there is three types of load balancer: application load balancer, network load balancer, and gateway load balancer. Mm, we will be using here an application load balancer that operates at the request level layer 7, routing traffic to targets, EC2 instances, containers, IP addresses, and Lambda function. Based on the content of the request, for more information, we can see a comparison of load balancers. So here I will create load balancer. VPC, lab VPC. Now we will specify which subnets the load balancer should use. The load balancer will be internet facing, so we will select both public subnet. In the security groups, we will choose the web security group. Here HTTP 80 and we will select lab group. Now I will create the load balancer. So successfully created the load balancer. This is the load balancer lab ELB. Now I will create a launch template and an auto scaling group. For this task, we will create a launch template for our auto scaling group. A launch template is a template that an auto scaling group uses to launch EC2 instances. When we create a launch template, we specify information for the instances such as AMI, the instance type, a key pair, and security group. So we launch templates, create launch template names, lab config. So I will enable this one, provide guidance to help me to set up template that I can use with EC2 auto scaling. My AMI web server. This is my AMI I just created. So for instant type, I will say select T2 micro. Key pair I can create, but now I will use this one for the security group. I will choose the existing security group. So for me, web security group. For the advanced details, so the cloud watch monitoring, I will enable this one. So now I will create launch template. Success, the launch template is created. So view the launch template. This is the launch template. Lab config. So for here, I can create auto scaling group. So auto scaling group name, I can give launch template, lab config, which I just created. So choose the next. So VPC, for VPC, I will choose lab VPC, availability zones, private subnet 1 and private subnet 2. Choose next. So attach existing load balancer, then existing, choose from existing load. Target group is this one, lab group. Additional settings. So next, additional settings, enable group matrix collection within CloudWatch. Then next, so this is not mandatory, this is optional. You can set it or no, so I will not set anything over here. So next, Mhm. Action, I will do it again. So here, size like under the group size, detail desired capacity 2, minimum capacity 2, maximum capacity 6. Then this will allow autoscaling to automatically add or remove instances, always keeping between 2 and 6 instances. Scaling policy. Target tracking policy. Target tracking name should be lab scaling policy. Lab scaling policy. Metrics. Average CPU utilization. Target value 60. And this tells auto-scaling to maintain an average CPU utilization across all instances at 60%. Auto-scaling will automatically add or remove capacity as required to keep the metric at or close to the specified target value. It adjusts to fluctuations in the metric due to a uh, fluctuating load pattern. So now I can next step 5 optional, so I will not do anything. Then next step 6, so I will add tag is name and value lab instance. Configure the detail in step 6, review the. So now I can create auto scaling group. So now I will verify that load balancing is working. In this task, we will verify that load balancing is working correctly. So we'll go to the instances. Here it should be two instances, new instances. Yes, we can see now two new instances, lab instance, lab instance. These are launched by auto-scaling if the instances or named are not displayed. Wait for 30 seconds and choose refresh in the top right button. Then we will confirm the new instances have passed their health check. So now we'll go to the target groups. Select lab group. Here two target group 2 is healthy. Target. See, there is two target here. Both are healthy. One is US East 1B and one is in US East 1A. We need to, if the status is not healthy, we need to wait for the healthy status. Now we'll go to the load balancer. Select this one. So what is the DNS name for this one? This is the DNS name. DNS name is A record. So I will open the web browser and paste the DNS name. So the application should appear in the browser. This indicates that the load balancer received the request, send it to one of the EC2 instances, then passed back the result. Yes, it is working. So now I will test the auto scaling. We created an auto scaling group with a minimum of 2 instances and maximum of 6 instances. Currently, 2 instances are running because the minimum size of 2 of the group is currently not under any load. We will now increase the load to cause auto scaling to add additional instances. For this one, we'll go to the CloudWatch. All alarms. See, the high alarm is okay and the low alarm is inefficient. Two alarms will be displayed. These are created automatically by the auto scaling group. This will automatically keep the average CPU load close to 60%, close to 60%, while also is there is two, it shows two alarms, both are inefficient data. So the OK indicates that the alarm has not been triggered. Now the CPU utilization is less than greater than 50. It is alarm for CPU utilization, which we will add instance when the average CPU is high. The chart show very low levels of CPU at that moment. Now we'll go here and we'll load the test. Yes, now the CPU loaded 100%. This will cause the application to generate high load. The browser page will automatically refresh so that all instances in the auto scaling group will generate load. So within less than 5 minutes, the alarm low should change to OK and the alarm high status should change to in alarm. So we can choose refresh in the top right every 60 seconds to update the display. We should see alarm high chart indicating an increasing CPU percentage. Once it crosses the, now we set it 50%, crosses the 50% line for more than 3 minutes, it will trigger auto scaling to add additional instances. So we need to wait until alarm high, alarm enters in alarm status. So now the alarm high is in alarm and low alarm is OK. Now we can look for the EC2 instances. It will create two more new instances. So here is 1, 2, 3, 4, 4 instances is running right now. So these two new instances were created by auto scaling in response to CloudWatch alarm. So now I will terminate the web server one. We don't, this instance was used to create the AMI uh, in your auto scaling group, but no longer needed now. So I will terminate this web server one. It is terminating. And this is all for today's lab. Thank you so much.